Hello students, in FYBSc class you have two courses in mathematics. So first course is MT-111 which is Algebra, and second course is MT-112 which is Calculus. First, this is FYBSc mathematics courses. So, and third course is MT-113 which is practical based on calculus, algebra and calculus first, and maxima software. So, in this video we will see first course algebra. So, in this algebra you have four chapters. So, first chapter is sets, relations and functions. Second chapter is divisibility, theory in integers, and third chapter primes and theory of congruences, and last fourth chapter is complex numbers. So first chapter, set, relations and functions. In that chapter we will see sets, relations, equivalence classes and partitions of sets, functions, next types of functions, inverse function and composition of function. So let's start first chapter, sets, relations and functions. So first see definition of sets or set, definition of set. So a set is any collection of well defined objects, and each object in the collection and each object in the collection is called an element an element of the set. Now for example, the set of alphabets in the world, set of alphabets in the world strong has alphabet S, T, R, O, N and G. These are 6 letters, S, T, R, O, N, G. So this is the set of all alphabets in the letter strong. So this is the set which is well defined. So if letters are repeated, then we take only single element. Note that the terms collection and objects are themselves undefined. Now the symbol, capital letters denote for set and small letters are denoted by elements of that set. Generally, capital letter denotes capital letters, suppose A, B, C up to so on. Z denotes sets, while small letters small letters. Small letters are small letters, small a, b, c, d up to so on, z are denotes, are the elements of, are elements of sets, are the elements of sets. Now small x belongs to capital X, means indicates that X is an element of set X, indicates that X is an element of set X. So X belongs to, this is the sign for belongs, means X belongs to capital X, means X is an element of set X and denoted by this notation. And we say that that X belongs to capital X. Now if X does not belong to X, so X does not belong to X means X is not an element of set X, indicates that, means X is not in set X, and we write, or we say that X does not belong to X, and we say X does not belong to set X. Now we will see some set. We are familiar with some set in previous classes. So sets, now the symbol capital N denotes set of all natural numbers, set of all natural numbers, and which are 1, 2, 3 up to so on. This is the set which has element 1, 2, 3 and denoted by letter capital N, which is set of rational numbers. Now next set is set of integer denoted by capital Z, which is the set of all integers, and which is -3, -2, -1, 0, 1, 2 and so on. This is set of integer and symbol capital Z. Next is Q. Q is set of all rational numbers. Q is set of all rational numbers, and rational numbers is always of the form P by Q, where Q always not equal to 0 and P Q belongs to what? Set of integer. Also we say that GCD of P and Q always equal to 1. So this is set of rational numbers. Now next set is real number. So real number denoted by capital letter R, which is set of all real numbers, which is collection of rational numbers and irrational numbers. Now next we will define subset. Now if we have two sets A and B, when we say that A is subset of B, if every element of set A are contained in set B, then we say that A is subset of B. So let we have two sets. Let capital X and capital Y denotes sets if each elements of each elements of capital X is also an elements of is also an elements of Y, then X is called capital X is called subset of set Y, and we write it as, or we denote it as X is subset of Y, means every element of set X are contained in set Y. For example, if Y denotes set of all students in the college, Y denotes set of all students in college, and X denotes scholar students in the college. X denotes scholar students in the college. Therefore, Y is set such that set of all students in the college, and X is the students which is scholar. So what we say that, so every scholar students are in the college, so X is subset of Y, then X is subset of Y. Again we have seen some sets here. So what is natural number? Natural number is 1 2 up to so on, and set of integer is from negative numbers -3 -2 -1 0 1 2 and so on, means every element 1 2 3 and so on are in set of integers which is 1 2 3 and so on, means what, set of integers is subset of set of natural number is subset of set of integer. So set of natural number subset of set of integer, and set of integers are subset of set of rational numbers. So this is the subset. Now next we will see equal set. When we say that two sets are equal sets. Now when we say that the given two sets are equal, means if we have two sets X and Y, if every element from set suppose I have two sets X and Y, if every element from set X is again subset of Y, and every element of set Y is again subset of X, then we say that both sets are equal. So we'll define equal sets. Now let X and Y denote sets if each element of X is also an element of Y, then so equal set, two sets X and Y are said to be equal, and we write X is equal to Y if X is subset of Y and Y is subset of X. If these two conditions satisfied, then we say that set x and y are said to be equal. Means x is subset of y and y is subset of x, then x is equal to y. For example, set up if x is set of alphabets in the world read, and y is the set of alphabets in the word dear, right? So x is the set here. What is given? X is the set of alphabets in the word. So what are the alphabets in the word read? So R, E, A and D. And what are the alphabets in the letter dear? So which is set Y. So Y has letters D, E, A, R, right? So in set X has 4 letters or 4 elements and Y has 4 elements. So R, E, A, D and Y has element D, E, A, R. So every element from set X is again subset of Y, right? So R, E, A and D means every element in set X is again in set Y, and every element in set Y is again in set X. So order is not important. So what we say that here every element in set X is subset of Y and every element in Y has is subset of X. Therefore both set X and Y are equal. Then set X and Y are equal. Now next we will see intersection of two sets. Intersection of two sets. Intersection of two sets. Now intersection of two sets X and Y is intersection of two sets X and Y is the set of those elements, is the set of those elements those elements which belongs to both X and Y, both X and Y, and denoted by notation X intersection Y. Means intersection of two sets means set of if intersection of two sets X and Y is the set of those elements which belongs to both sets X and Y. So by Venn diagram, suppose I have set this is set X and this is set Y. Then what is the intersection? Intersection is the common point belongs to set X and Y. So what are the common points between these two sets? So this is the common point. So the shaded region is, this shaded region is the intersection of set X and Y. This is shaded region is X intersection Y. For example, now if I have set X has element 1, 2, 3, 4, 6, 12 and Y has element 1, 2, 4, 8. Then their intersection means common points between these two sets are X intersection Y. So what are the common points? 1, 2, so 3 is not common, 4, 8 is not common. So X intersection Y is 1, 2 and 4. Now Next we will see union of two sets. Union of two sets. Union of two sets. Union of two sets x and y is the set of those elements which belongs to at least one of set x and y, and denoted by notation x union y. So what is the union? Union of two sets x and y is the set of all those elements which belongs to at least one of the set which is either in x or y. All the collection is x union y. For example, if I take set x whose element 1, 2, 3, 6 and another set y whose element 1, 2, 4, then their union will be x union y. So what is the definition? X union y is set of all those elements which belongs to either in x or y. So 1 means every element which is either from x or y. So all the collection in x union y. 1, 2, so 3 is here, but here 3 in first set, but 3 is not in y, but which is at least in one set. So 1, 2, 3, 4, 6. So this is the set x union y. So next is and union of two sets denoted by Venn diagram. Suppose I have set this is set x and this is set y, then x union y is set of all those points which belongs to at least one of the set, means all the points which are contained in these two sets. So this is x union y. Shaded region denotes x union y. Now we will see next point, complement of set. Now we see complement of set. Complement of set. Now suppose I have set u, let u be the subset of the set x, then the set u complement is set of all those points x belongs to capital X, but x does not belongs to u, is called the complement of u, is called complement of u in x. Now for it denoted by Venn diagram. Suppose I have set u is subset of x. So this is set x, this is set x, and u is subset. So this is u is subset of x, and then u complement is set of all those elements x belongs to capital X such that x does not belong to u. So set of all those points which excludes u, means the region will be like this. So this region is u complement. So here is u complement, and this is whole set x. So u is subset of x, then u complement is set of all those points which does not belong to u, and x which belongs to x. So this is the region for complement of set U. Now for example, the shaded region is U complement. Set up all those points which belongs to x but x does not belongs to U. For example, I will take, suppose I have, if x is the whole set which is 2, 3, 4, 5, 6, 7, 8, 9, and U is subset of that set. So U is 2, 4, 5, 7, and 8. Then what is U complement? So what is the definition for U complement? U complement is set of all elements x belongs to x but x does not belongs to U, right? So means set up all those points which does not belongs to U, means we take only elements from set x which does not belongs to U. So the remaining elements should be 3, 4 is here, 5, 7, 8, 2, 3, 6, 9. So the U complement is 3, 6, 9. So this is the complement of set U. Now next lecture we will see De Morgan's law and power set. Thank you.